Hello, it's Mrs. Maths here, and I am back with another video for you. We are looking at the 2019 Leaving Cert Ordinary Level Paper 1 Question 7. It is a functions and calculus question. I hope you find it really helpful, and if you do, give it a big thumbs up. Don't forget to head over to my Facebook and my Instagram page. I have lots of content over there as well. So let's get started. Starting with part A of question 7, we have a camogie goalkeeper on a level pitch, hitting a ball straight up into the air. The path that the ball is travelling can be modelled by the function. We have minus 4t squared plus 16t plus 1. And they tell us here that t is an element of the real numbers, which means t can be any number ever that exists, so you're not just going to be dealing with whole numbers here. T is time in seconds after the ball is hit. The function represents the height of the ball in meters above the pitch. The ball landed on the ground without being hit again. So essentially what's happening here is the goalkeeper is hitting the ball up into the air, and we are modelling the path that that particular ball takes in terms of its height and the time. Part A then asks, at what height was the ball when it was hit by the goalkeeper? If you think about the instant that the goalkeeper hit the ball, we would say that time is 0 at that stage. So we know that t stands for time. We're going to sub in 0 for t into our function. We do that. Always show your workings. Always show that you've subbed in a number into an equation or into a function. Work it out, and we find that it's 1 meter. At the instant that the goalkeeper hit that ball, we know that the ball was 1 meter above the pitch. Looking at part B, part I, they tell us to complete the table below and show the height of the ball at various intervals during the first 4 seconds of its flight. So as you can see here, the time is being looked at in half seconds. We know from part A that when the time is 0, the height is 1, but we do need to work out the rest of them. This one here at 2.5 seconds, the ball is at 16 meters high. You need to do your subbing in for 0.5, 1, 1.5, 2, 2.53, 3.5 and 4. Now I have done the 2.5 on here just to show how we would have got 6. You're not necessarily required to put that one in. I always highlight my answer so it's very easy for me to see. Make sure you put the answers back into the grid. That's what they're asking you to do. And please show your working. You must show your workings. If for some reason something goes wrong and you've no workings, you get a big fat 0. In some cases, or most cases, if you do show some of your workings, at least there might be some merit in your work and you might get some mark. All the little bits of marks add up, and sometimes it can be difference between a grade. In B part 2, you are asked on the grid below, draw a graph to show the height of the ball while it is in the air. You've done the work previously, you have all those coordinates that you got in part I, and you are literally going to plot them. So 0, 2, all the way around. Make sure that you plot all of them, because that's how this graph question would be marked. You'd be looking that all of those points are on the graph. I have done my graph in a red pen here, which is contradictory to what I'm going to tell you, but I have done a red pen for the purpose of the video and so you can see it. If you are inclined to draw wobbly graphs, use a pencil. You can easily adjust it and you know, look at your curve and adjust it, make it smoother if you're using a pencil. With a pen, it's just going to be a big mess. Then you're messing with tip X and it's just a nightmare. So please use pencil for these. Make sure that you've got a nice curve, consistent curve. Put a bit of effort into that as well. Always take note about what axis represents what information. So your x-axis is representing time, which is t, and your height is represented on the y-axis in terms of meters, in terms of m. So B part 1 and 2 got 20 marks altogether combined. Part C, it asks us to use our graph to estimate 2 different pieces of information. The length of time the ball was in the air from the time it was hit until it landed on the ground, and the length of time the ball was 10 meters or more above the ground. In part C, you are asked to use your graph to estimate 2 pieces of information. The first piece of information is the length of time the ball was in the air, from the time it was hit until it landed on the ground. And the second one is the length of time the ball was 10 meters or more above the ground. Remember, and I have it highlighted here, you must show this work on your graph. You literally will get 0 if you don't show this work on your graph, even if the answers are correct. They only want you to use your graph. There is no algebra needed here. They don't want to see it. Each part is worth 5 marks and you must show it on your graph. I cannot stress that enough. Take a different color pen and mark this information onto your graph. So the first part of C was how long was the ball in the air? It was in the air from 0 until just past 4. So when you plotted your points, your last point was 4, 1, which is this point here. And if you extend that, so I extended my graph past 4 on the right hand side, so I extended it fully in the same manner that it was continuing, and it looks as though I am at 4.1 there. So from 0 to 4.1, that's how long it was in the air, which is 4.1 seconds, because our time is measured in seconds in this question. And if you weren't sure about that, it does tell us that at the very start. So don't be afraid to go back and double check that. Make sure your measurements are in the right unit. Part 2 was find the length of the time the ball was 10 meters or more above the ground. So you go to your y-axis and you look for 10 meters, and I drew a dotted black line straight across the graph. And I'm looking for where my graph hits that. Between this point and this point, my graph was over that 10 meter line. So this part here. So when the ball was moving along here, it was 10 or higher. I need to identify that part of the graph. You always use the x-axis to identify where something is happening on a graph. So I take my ruler and I bring a dotted line right down here, and I appear to end up at 0.6. I do the same on this side. I bring my dotted line down and I look to be at the 3.4 mark. This is where drawing a nice smooth curve is really important, because the smoother and the more accurate your curve is, the more accurate these estimations will be. There will be a margin of error that examiners will give you, but it is quite small. The quality of graph will lead on to correct answers, so it's very important that you connect those two jobs together. So we can see that between 0.6 and 3.4, between those two times, the ball was 10 meters or higher off the ground. We need to know the length of time. If I go back down here to my boxes, in this case what I've done is I have found the difference between them, because I want the amount of time it was above 10 meters. The biggest subtract the smallest gives me 2.8 seconds. So there was a window of 2.8 seconds where that ball was 10 meters or higher. We are now on part D, part 1, and this is a differentiation question. So you can see the word derivative there, or you can see the f dash of t symbol. So that tells us that we have to do some differentiation. So when you're doing differentiation, you're asked to do differentiation, have a quick look and observe what kind of function you have. Do you need to use any of the rules, the product rule, the quotient rule, etc.? So you can see here we've just got our normal function and we've got 3 terms in the function. This is a straightforward differentiation question. I have written down the rules for differentiation for this type. This is straight from your log tables. Lots of information on differentiation there, so make sure you have a look at it and you're familiar with it. See, what you're doing is you're taking the power on the x, you're bringing it down and multiplying it at the front, and then you reduce your power by 1. So if we look at minus 4t squared, I am going to bring down my power, which is 2. So minus 4 multiplied by 2 is minus 8. Write down my variable, which is t, but I'm going to reduce the power by 1. So 2 minus 1 gives me 1. What happens here with 16t is that I bring down the power. So the power here is 1. Bring down the power, it doesn't change 16. I reduce the power of t by 1, which 1 minus 1 would give me 0. Anything to the power of 0 is 1. So that's how I get 16. And the derivative of any constant is equal equal to 0. That information you would have done when you've studied differentiation. That is a nice little 5-mark question. If you found this difficult, make sure and go back and do a little bit of revision on your differentiation rules. Moving on to D part 2, they're asking us to use our answer from part 1 to find the speed of the ball when it has been in the air for 4 seconds. Give your answer in meters per second. They're asking us to use the differentiation, so the minus 8t plus 16, and we want to know the speed when it has been in the air for 4 seconds. So our time is 4 seconds. So I have subbed that in for t, I have worked it out, and I got an answer of minus 16. There is no such thing as a negative speed, so we will take the positive version, so we will say that the speed is 16 meters per second. And lastly, looking at part 3 of section D, they say use your answer from part 1 as well to find the value of t for which the ball was descending and travelling at a speed of 8 meters per second. The equation we get from the first derivative in an application or a context like this describes the speed of the object. So the original function that we had at the very start represents the height or the distance from the pitch in terms of time. The first derivative, which is what we have here in front of us, minus 8t plus 16, that represents the speed of the slitter as we go through the time that it's in the air. I can let my function minus 8t plus 16 equals minus 8, and you simply just solve that equation for t. You do your bit of number crunching there, getting the t on the left and the numbers on the right, and you'll find that t is equal to 3, which means 3 seconds. Ball is descending for 3 seconds. That is the end of the 2019 Leaving Cert Ordinary Level Paper 1 question 7. Make sure you like this video if you found it helpful. Don't forget to subscribe so you can keep up to date with all of my newest videos. Leave a comment down below if you have any suggestions of videos I can do in the future, or if you just have some questions. And remember, Mrs. Maths Ireland is very active on Facebook and Instagram, so don't forget to go over there and give me a follow. Thank you for watching, and I'll see you in the next one.